All right, today we are talking about the inside of the Earth. What are we walking on? All right, so the Earth's layers, which we briefly discussed in the warm up before, it's divided into four main layers. You have your inner core, outer core, mantle, and crust. So we'll start with the crust. Normal people don't like the crust on the bread. It's on the outside, right? We don't. Anyway, so the crust. So the Earth's crust is kind of like the skin of an apple. It's very thin compared to the other three layers. So it's a very thin layer. It makes up about 1% of the Earth. So if you think about that, it's very small, 1%. So the crust of the Earth is broken into many pieces called plates, tectonic plates. And we will talk about those later on. So the crust, it's only about 3 to 5 miles or 8 kilometers thick under the oceans, and 25 miles or 32 kilometers thick under the continents, continental crust versus oceanic crust. So the continental crust is much thicker, about 3 times, 3 to 4 times thicker than the oceanic crust. So some more facts about our good old crust here. It's the outer layer, right? Skin of the apple, 5 to 100 kilometers thick, depending on the area. There's two types of crust. We have that oceanic, which is very dense, and it's made of basalt. And then you have continental crust, which is less dense, and that's made of granite. So then we know that basalt is thicker than granite rock. So here we have a picture of oceanic versus continental crust. As you can see here, the oceanic crust is thinner, right? And if you look at the arrows there in the middle of the picture, you see how the oceanic crust is going underneath the continental crust as those plates are moving. So if there's a convergent boundary where they're going together, the oceanic crust, because it's more dense, right? More dense things go to the bottom. It is sliding down underneath that continental crust, and going down into, as you can see here, the mantle. So here we have another picture of our oceanic versus continental crust. You can see here if there's a divergent boundary, diverge means to go away. If both oceanic crusts are going away and then down underneath the continental because they're more dense, magma rises up, and this is called seafloor spreading. So when the seafloor spreads, okay, when it spreads, magma from the mantle comes up and it creates new seafloor. Recap time. All right, so list at least 3 facts about Earth's crust. So we just talked about many facts about the crust. List at least 3 of them. And then what are the 2 types of crusts and which one is thicker? All right, the mantle. So the mantle is the most solid bulk of Earth's interior. So most of the Earth's interior is the mantle. It lies between the Earth's core and its outer layer, the crust. So it's in between. So it goes crust, mantle, and then core. The mantle is about 2,900 kilometers thick. That is pretty thick. And the mantle makes up a whopping 84%. 84% of the Earth's total volume. So 84% of the Earth's total volume. Recap time. Quick turnaround there. What are 2 facts about the Earth's mantle? 2 facts about the mantle. And where do you find the mantle within the Earth? So where in those layers would you find that mantle? The outer core. So we've worked our way from crust to mantle now to the outer core. As you can see here, the core of the Earth is like a ball of very hot metals. So the outer core is actually liquid. So the outer core is liquid. The outer core is made up of iron and is very dense. So it's super dense, made out of liquid iron. Now the inner core of the Earth has temperatures and pressures so great that the metals are squeezed together and are unable to move. So then that makes it a solid. So because it's under tremendous amounts of heat and pressure, those metals then get squeezed together and cannot move, so they become a solid. Recap time again. So compare and contrast the inner versus outer core of the Earth. What are their states of matter? So solid, liquid, or gas. Where are they located? Right? Which one's further inside the Earth than the other? And what makes them different? How are they a little bit different from one another? So another look at Earth's layers. So how are the Earth's layers similar to an egg? So another real life comparison, if you hard boil an egg, The shell is the crust, right? It's very thin on the outside. You have the mantle as the bulk of it, the egg white, and then you have the yolk as the core. So the physical structure of the Earth. So the lithosphere is the outer layer, which is also considered the crust, and the asthenosphere is the solid rock that flows slowly, like hot asphalt. So our lithosphere, also referred to as the geosphere, remember back to our spheres project, long time back in the day, it's the solid part of the Earth. It has two parts, the crust and upper mantle. So the lithosphere sits on the asthenosphere. So the lithosphere sits on top of the asthenosphere. The Earth's plates are the asthenosphere. So our tectonic plates that you learned about in previous years, that is what the lithosphere is. It's the rocky solid portion of the crust. Remember that it's made up of mostly silicone and oxygen. So the lithosphere is made up of silicone and oxygen. The asthenosphere. The asthenosphere is the layer below the lithosphere. It's called the plastic-like layer. Okay, it's somewhat solid, somewhat liquid. So it's a liquid solid. You can say that's malleable, right? Malleable, able to be bent. It's very important in terms of plate tectonics because plates are always moving. So to be able to move, those solid plates of the lithosphere have to be able to move on top of that solid, liquid, malleable asthenosphere. So let's take a peek at what that looks like. So you have the lithosphere in red here with the arrow. And then you have that plastic asthenosphere, which is here. And so you can see that they're both inside. The lithosphere is in the crust, and the asthenosphere sits on the border of that crust and that upper mantle there. Right? And that lithosphere, those plates slide on that plastic asthenosphere. Recap time. Compare and contrast the Earth's lithosphere and asthenosphere. So you can do like a T-chart, lithosphere and asthenosphere, and list some facts for each one. You can do a compare contrast bubble, double bubble, whatever you would like to do. Where are they located? What is its state of matter? Is it solid, liquid, etc.? Any facts about them that you feel are important that were listed in previous slides. All right, and then finally, the tectonic plates, and we'll go into this more later, but remember the plates are the lithosphere. It's broken into about 19 plates. We're only going to focus on the main 7 of them. But here you can see the main ones are the North American, Eurasian, African, South American, Indian, Australian, and Antarctic plates, which are they're highlighted, and the Pacific plate, which is highlighted in black. So those 7 that are in black, those are our main ones. The small little plates that you see in red, like the Arabian plate there in the middle, or the Caribbean plate, we're not going to focus so much on those. We're going to focus just on those main 7 that are located here in black, and we'll be going over those later. But these plates, remember, they move on top of the asthenosphere. So the asthenosphere is here. Those plates are on top of it because that asthenosphere is allowing those to move. All right, make sure you make a brief note about those in your notebook and get ready to make your foldable.